Very good morning. Myself, Dr.M.Selvam, Associate Professor, Department of Mechanical Engineering, Railtech Multitype, Dr. Rangarajan, Dr. Savundala Engineering College. Now I'm going to present our research topic as sustainability of biofuels and renewable chemical productions from nano-reduced blended biodiesels. This is our abstract of research work. Our research work investigated with the CRDA CA engines. We are using different fuel samples. The samples are pure biodiesel, 30% biodiesel, biodiesel with 15% EGR, and individual nanoparticles of cerium zirconium oxide and combined nanoparticles of cerium zirconium oxide with 15% EGR were investigated in this experimental research setup. So finally, the superior sample fuels of 30% biodiesel, 25 ppm of cerium oxide, 25 ppm of zirconium oxide with 15% EGR displayed better performance compared to other samples. This result shows highly increasing the brake thermal efficiency and reducing specific fuel consumptions. 8% brake thermal efficiency increased and 9% specific fuel consumption is reduced compared to diesel. Also, the combustion characteristics and the heat release rate were increased to 4.3%, 2.8% respectively. Finally, this fuel samples of emissions characteristics also highly reduced. Carbon monoxide, hydrocarbon, nitrogen oxide reduced by 30%, 19% and 13.3%. This is our introduction of research work. We know that compression ignition engines are widely used due to fuel economy compared to SI engines. For this reason, we have been using IC engines. IC engines fuel cannot be completely converted to useful work because we cannot achieve 100% thermal efficiency. The efficiency minimum 30%, maximum 40%. The coated engine results can more better brake thermal efficiency, specific fuel consumption and reducing emissions. When biodiesel can be run with, actually the engine can be run with biodiesel, additional benefits compared than diesels. When we are using biodiesel in CA engine produce high combustion performance and reduce harmful gases like carbon monoxide, hydrocarbon. Actually, we know that biodiesel is a renewable fuel and eco-friendly alternative fuel compared to diesel fuel. It has a higher viscosity, density, flash point, fire point, cetane number compared to diesel fuel. Biodiesel, it is a natural fuel. It contains more oxygen content present in biofuels, 10 to 15% of oxygen present in biodiesel, and also it is a sulfur-free fuel because there is no sulfur content present in biodiesel. For this reason, we are selecting biodiesel as an alternative fuel in this research. Next, 100% biodiesel we cannot run in CA engines. If you use 100% biodiesel in CA engines, it produces less engine performance and less combustion performance. For this reason, the optimized blend of biodiesel it can be used in CA engines. It improves the engine performance, reducing all the emissions except hydrocarbon, carbon monoxide, nitrogen oxide, unburned hydrocarbons. When we are using biodiesel, it is a CA engines. It is a suitable alternate fuel, and it shows lower marginal engine performance and reducing hydrocarbon, carbon monoxide, carbon dioxide compared to diesel. But when we are using biodiesel in CA engine, it has some demerits. The NOx emission is highly increased compared to other emissions. So how we control the NOx emissions? If we added EGR in the system, we can control the NOx emissions, but alternatively other emissions are highly increased. So how we control including NOx emissions? So what are the technologies are implementing in this experimental setup to overcome these drawbacks? The nano additives played a vital role. So in the setup, we have been using nano additives with EGR to overcome all the. These are applications of nanoparticles. Nowadays, nanoparticles played a vital role, and it will be used various sectors to improve their performance and increasing the efficiency. This slide shows us what are the nano additives are used blended with the biodiesel. Different oxides are used: aluminum oxide, titanium oxide, zirconium oxide, cobalt oxide, etc. This nano oxides with a different dosage level is blended with the biodiesel 25 ppm, 50 ppm, 80 ppm, 100 ppm respectively. After adding nanoparticles, how the nanoparticles performed based on the literature survey, it was analyzed. Once nanoparticles added in biodiesel, the brake thermal efficiency is highly increased and reduced brake specific fuel consumption, and also increased combustion performance of cylinder pressure and heat release rate, and reducing emissions hydrocarbon, carbon monoxide, nitrogen oxide, smoke, particulate matter, etc. The many reviewers accept nanofuel records a better performance compared to biodiesel. Once nanoparticles added in biodiesel, the problem is there. What problem we identified? The first one is lack of stability, second one is poor suspension quality. To overcome this drawback, once nanoparticles added in biodiesel, nanoparticles, solid particles, all the nanoparticles are settled at the bottom of the fuel tank. It is not equally disposed in the fuel tank. To overcome this issue, we are using ultrasonic shaker. It is a mechanical vibrations. Once it is added in nanoparticle blended biodiesel, all the nanoparticles are equally disposed in biodiesel. Second one is chemical surfactant. We are using oleic acid. The oleic acid is added blended with biodiesel. The oleic acid is formed around the layer of around the nanoparticles. It makes a good suspension quality. So all the nanoparticles are the stability of nanoparticles will be improved once added nanoparticles. So the disposal of nanoparticles in biodiesel is uniformly dispersed. Finally, after adding nanoparticles, we find out the nanoparticle structure, size, shape. It is found out through the scanning electron microscope test. This is our objective of our research work. The first added nanoparticles. After nanoparticles added in biodiesel, it find out the fuel properties of viscosity, density, flash point, fire point, calorific value, cetane number, etc. It is compared with the diesel as per ASTM standards. Next, investigate coated and uncoated engines, how the brake specific fuel energy consumptions and brake thermal efficiency and combustion characteristics were investigated with the help of diesel and biodiesel added in fuel in both engines. Next, investigations, engine performance, combustion characteristics, heat release rate, cylinder pressures, all the characteristics are measured in CRD engines after using nanofuels. Next, to evaluate the characteristics of emissions of biodiesel nanofuel. To find out in CRD CA engines, the emissions characteristics are hydrocarbon, carbon monoxide, carbon dioxide, particulate matter, smoke and NOx. Finally, the exhaust drain device is needed to investigate the exhaust gas. After the exhaust gas released to the exhaust systems, it will be circulated to the combustion chamber with the help of EGR. EGR, it is most suitable to reduction of NOx emissions. This is our literature review. Actually, the literature review, it is reviewed from various international journals after adding nanoparticles, after adding biodiesel, how the engine is performed, of engine performance and the combustion performance and the emission characteristics. The first author is Harish Venu et al. In the year of 2020, he using aluminum oxide nanoparticles blended with a single cylinder diesel engine. After running this fuel, higher brake thermal efficiency, lower brake specific fuel energy consumptions, and also reducing all the emissions, hydrocarbon, carbon monoxide, nitrogen oxide, smoke, reducing by 5.69%, 11.24, 9.39 and 6.48. The next author, Sivakumar et al. In the year of 2018, he using aluminum oxide in single cylinder engine. After running this setup, increasing NOx emissions and reducing ignition delay, it is a major drawbacks, and producing lesser hydrocarbon. The next, S. Karthikeyan et al. In the year of 2016, he used cerium oxide. After cerium oxide blended with biodiesel, it may be highly reducing brake thermal efficiency and reducing brake specific fuel consumption, reducing all the emissions. Next, Sajid V et al. In the year of 2015, he used combined nanoparticles blended with biodiesel, produced including reducing NOx emissions. Based on the review, we find out different edible to non-edible oil fuel properties. Why we are selecting rice brown oil. Based on the literature review, the rice brown oil density value is very lower compared to other edible oils, and the viscosity of rice brown oil, I think it is very lowest values compared to other edible oil. Flash point, fire point also the value also. So proved better results compared to other edible oil. For this reason, we are selecting rice bran oil as a bio through this fuel properties setups. This slide shows us why I have selected cerium zirconium oxide nanoparticles and rice bran oil as a biodiesel, oleic acid is a surfactant. We have more reasons for selecting this fuel setup because we Sajid et al. TBR analysis technique, he find out individual nanoparticles and the combined nanoparticles. Individual nanoparticle released a higher heat release rate compared to combined nanoparticles because it proved better results. Second one, different dosage level blended biodiesel were investigated. The higher dosage level nanoparticle blended with the diesel, it released a higher brake thermal efficiency. For this reason, cerium zirconium oxides added nanoparticles to blend with biodiesels. Next, why I have selected rice bran oil? Rice bran oil, we know that is the mass production in India. It contains 16 to 13% of weight of oil compared to other edible oils. And also the rice bran oil, it has more fuel properties of chemical, physical and thermal properties. Values are nearer to diesel. For this reason, we are selecting rice bran oil as a biodiesel for this research experiment. This is a research gap identified based on literature review. Actually, minimum works were reported on non-additive of cerium zirconium oxide blended with biodiesel. Next, advanced fuel injection system is needed. After adding nanoparticles, what will happen? Fuel fragmentations of air fuel mixing and spray angle, it is a poor performance after adding nanoparticles. So advanced fuel injection system, maybe high fuel injection system, it will be needed to avoid this problem. So advanced fuel injection meter, minimum 600 bar, maximum 1000 bar fuel injection pressure is needed, system is needed. Next, problem of injector choking. When added nanoparticles, all the nanoparticles are solid particles. These particles block the injector hole. To avoid this issue, we have high fuel injection pressure is needed to avoid the injector choking problem. And the next one is suspension quality, major issues of suspension quality. Once we added oleic acid to avoid the poor suspension quality and also accumulation of nanoparticles in base fuel. Once oleic acid is added, it will be increasing the suspension quality of fuel. Next investigation is after adding nanofuel, thermal properties of nanofuels combustion, it will be investigated in this experimental setup. Next, exhaust treatment devices are needed to investigate the effect of non-reduced exhaust gas, because exhaust treatment device means EGR is investigated in this setup. Once the EGR it is added in the system, we can reduce NOx. This is our work plan of our experimental setup. This slide shows us first the raw oil is extracted from vegetable oil. After producing vegetable oil, next transesterification is needed to convert to biodiesel. Methanol and KOH is separated, titrated separately. After titration process of methanol KOH blends, these blends is poured to the heated oil. After this chemical process, the crude glycerol is removed separately with the help of separation process. Next, removing all the glycerol, light density fuel is stored in separate funnel. Then all the fuels contains impurities. To remove the impurities with the help of distillation process, water wash process, it will be all the impurities will be removed. Finally, the pure biodiesel is blended with biodiesel. Here, nano-reduced surfactant diesel is added to produce nanofuel. Once nanoparticles added in biodiesel, what will happen? All the nanoparticles settle at the bottom of the fuel tank. To avoid this system, we are using ultrasonic system. Finally, the nanofuel is ready to run in diesel engines. This process shows us how biodiesel and nanofuel is produced. First, oil heating process. First, oil is taken separate class beaker. The quantity of oil is 1000 ml and it is heated up to 70 degrees Celsius with the help of electric heater. The second process, titration of methanol and KOH. Methanol and KOH titrated separately. 1% of KOH, 15% of methanol is blended in separate measuring cylinder and it is mixed together, measuring cylinder with the help of glass rod to attain complete blend. Finally, this mixture is poured in heating oil. Third one is stirring of oil. The oil and methanol blend is immediately transferred to the stirring mechanism. Stirring process started. Stirring time taken is 45 minutes to 1 hour. With the help of stirring mechanism, the mixer completely blended. Finally, this mixer poured into the separator funnel. Next process, glycerol separations. After 24 hours, the glycerol is settled at the bottom of the separator and oil is settled at the top of the separator. Now the glycerol is separated by opening valve screw mechanism and it is stored in a separate container. The crude biodiesel. This slide shows us how the soap oil is removed from biodiesel. This process is water wash process. After removing glycerol, oil is separated in a container, but it contains high amount of impurities that can be removed with the help of water wash process. Now 20% of water is heated up to 40 degrees Celsius. Then it blends with oil. Then it is blended with oil. Again, this mixture is transferred to the stirring mechanism for the stirring process. After stirring process, it is stored in the separators. Next process is remove the water from the oil. After 28 hours, soap oil is settled at the bottom of the separator. Oil is settled at the top of the separator. Soap oil color is milky white and it is separated by valve opening screw mechanisms. Finally, the oil is stored in a separate container. Finally, the oil is heated up to 120 degrees Celsius to evaporate the excess water. After producing cleaned biodiesel. This cleaned biodiesel, next nanoparticles are measured with the help of electronic weighing scale. After measuring the nanoparticles 25 ppm of cerium oxide, 25 ppm of zirconium oxide is added in, blended with diesel. This blend of nano fuel is transferred to the ultrasonicated mechanisms. Why the nanoparticle blended biodiesel transferred to the ultrasonicated mechanisms? Because all the nanoparticles added in biodiesel, all the nanoparticles are not equally disposed in biodiesels, so all the nanoparticles settled at the bottom of the fuel tank. To avoid this issue, to produce nanoparticles are equally disposed in the fuel tank, we are using ultrasonic mechanism device. Then finally we can produce nanoparticle blended biodiesels. The color is milky white. Now the nano fuel is ready to use in CRDA engines. These are process parameters of trans-esterification process. Reaction temperature 55 to 70 degrees Celsius, sample oil 1000 ml, methanol and catalyzed of KOH 120 ml per kg of oil, 0.5 to 1% of kg of. Reaction time and settling time 8 to 12 hours, water was 2 to 3 times, stirring speed 400 rpm. After producing biodiesel, this fuel may be suitable for CRDA engines, and also this fuel is nearer to diesel fuel properties or not. It will be identified and found with the help of various instruments. First, the electronic weighing scale, we can measure the fuel density, nano fuel density, diesel density and the biodiesel density. It is measured with the help of electronic weighing scale. So what is the density value of different fuel samples? Next, viscosity. Viscosity is a major role played in fuel properties. The viscosity is measured with the help of reduced viscometer of different fuel samples. Next, flash and fire points. Once the oil is heated with a closed cup apparatus, oil is heated up to it reaches more than 50 degrees Celsius. First, the fire is close to the oil. What will happen? First, flash is happened. Next, after 60 degrees Celsius, it reaches, fire is happened. So through this setup, we can measure the flash point and fire point temperature of different fuels. Next, form coloring meter. It will be help to identify the fuel calorific value. Through the calorimeter, we can find out all the fuels of calorific values. Next, FTR spectrometer. It is used to identify fuel structures and fuel atom strength and fuel quality with the help of FTR spectrometer. Finally, the fuel properties of different sample fuels were investigated in this table. First, diesel fuel values, we know that we identified diesel values of density 820 and kinematic viscosity 2.72, flash point 56, fire point 62, calorific value 45,000 and cetane number 48. All the samples compared to diesel, finally the superior fuel of nanoparticle blended biodiesel results better results, and it is close to the diesel values. So for this reason, this fuel results performance, combustion performance and emissions characteristics and fuel property, physical and chemical property values all are nearer to diesel. For this reason, this is a superior sample fuels of combined nanoparticle blended biodiesels.